This is section 2.1.1 and 2.1.2, the introduction to electric fields. The goal of electrodynamics is to ultimately determine the forces that a charge feels in a field that is generated by other charges. Okay, so let's define some language we're going to use. First, we're going to define things like our source charges. It can be some collection. In this case, I'm going to draw them as discrete charges. I'll call that little q1, little q2, 3, 4, 5. Right, and I've arranged those just arbitrarily. These are called our source charges. Now, I can have any kind of distribution I want of these source charges. These charges generate a field. I can think about them having some sort of electric field, or if they're moving, generating a magnetic field. But ultimately, I want to know what's the force that is felt by some test charge, capital Q, as a result of my source charges, little q. So if I know what the force is, then I can go ahead and determine the trajectory, and then I can describe completely the motion of my test charge particle. Now, in general, this problem is too hard, right? So I've set up something that seems simple, but is really challenging because, not only are these source charges generating fields that are applying or generating forces on my test charge, but my test charge also can generate a field too, and which would then affect my source charges, and it's this infinite loop. Okay, so eventually the book gets there, but we won't in this single quarter class. But what we're going to do is build through a series of problems a set of skills that will help us prepare to answer this question. All right, the first simplifying assumption we're going to make is that our source charges are stationary. Okay, static. You'll see words like electrodynamics and electrostatics. All right, we were talking about electrostatics. Okay, so with a static set of test or of source charges, I want to know what's the force on my charge Q. All right. And you might have seen this before. Let's go ahead and look at a single source charge generating a field. Okay, I have a vector that points from my source charge to my test charge. By definition from the last chapter, right? We call that script R. Now I'm going to go ahead and make it a distinction that that's script R1 because it points from test charge or source charge 1 to my test charge. And I know Coulomb's law from my previous E&M course, which tells me that the force from charge 1 on my test charge is then equal to 1 over 4 pi epsilon naught my source charge, which is generating that field, my test charge, the magnitude of that distance squared, and it's in the direction of that vector. This is Coulomb's law. All right. The way I remember this squared on the bottom is thinking that I have this surface area of a sphere. Surface area of the sphere goes by 1 over r squared. Okay. And you see this epsilon naught that exists. That is the permittivity. And it has a value. I don't think we may very rarely actually plug in the value. That's 8.85 times 10 to the minus 12 Coulomb squared, Newton meter squared. Okay, so because these are pairwise interactions, I can go ahead and find the total force, which is just the sum of all of my individual forces. Let's erase that sum. F1 plus F2 plus F3. All right, I have three of them because I have three source charges, which is just 1 over 4 pi epsilon naught Q1 times Q over R1 squared in the R1 hat plus Q2 capital Q R2 squared R2 hat plus, guessed it, Q3 capital Q script R Q3 squared in the script R3 hat direction. All right, and if there were more charges, we'd have more, right? But we only have three in this example. You'll notice that the Q, the capital Q, my test charge, is the same in all of them. So I can pull that out. That's Q over 4 pi epsilon naught Q1 R1 hat over R1 squared plus Q2 script R2 squared plus Q3 script R3 direction script R3 squared. Which means that my total force can be rewritten as Q, my test charge, and all of this is just the total electric field. That's the electric field that's being generated by all of my single point charge, all of my single source charges, Q times E. All right, so ultimately the goal of finding the force, right, that a test charge feels, it all boils down to calculating what the electric field is from this set of stationary particles. So if you can do that, if you can find out what the electric field is, which is independent of my test charge, then if I put a test charge at that point, I can figure out what the force that it feels is.